Welcome, everyone, to the third lecture, Harmony in Faith and Science, a 6-lecture series sponsored by the Asian Patrons of the Arts at the Vatican Museum. The response has been incredible, and the past 2 lectures, we had more than 250 joining us, and today we are actually at 200 because there are 50 others who haven't registered but who went in on the Zoom. So welcome everyone. So let's now continue with today's lecture, and I'm honored to be the moderator today. And before we start, you will note that all your laptops have been muted. And yes, you can ask questions. There is a button at the bottom for question and answer. Please type in your questions as Brother Guy proceeds, and it will be answered as much as we can. Otherwise, it will be sent to you by email. So today, we're in for a treat as we sit back and let the world-renowned Brother Guy Consolmagno guide us through his cosmos, Catholic Cosmologies, from St. Paul to the Big Bang. As you can see in the slide, as long as humans have been trying to make sense of the universe, they have been proposing cosmological theories, from angels and demons to protons and quarks. So, what is the cosmos? How do I fit in? Well, we will let Brother Guy enlighten us. Brother Guy is a Jesuit brother, the director of the Vatican Observatory, one of the oldest astronomical research institutes in the world since 1891. You will hear more about the observatory actually at the 5th lecture on the 10th of July. And one more thing about what Brother Guy does with the Vatican Observatory, is also the president of its foundation, which promotes education and public engagement in astronomy. So how does a young man from Detroit with a doctorate in planetary science and numerous scientific fellowships in esteemed institutions like MIT, Fordham, Harvard, among others, and a writer of very popular astronomy books, he is very popular, Would You Baptize an Extraterrestrial, being one of them. And of course, he's written hundreds of scientific publications. So how did Brother Guy end up in astronomy and as a Jesuit brother? Well, the answer actually lies in the stars of Brother Guy's childhood. As a young boy of 10, as he grew up spending summers at Lake Huron, clutching his favorite book, which was the famous H.A. Ray's The Stars, A New Way to See Them, in his little hands, this boy made friends with a multitude of stars above, from Gemini, Taurus, the Big Dipper, and of course his favorite star, Arcturus. Well, the stars of Brother Guy's childhood may have brought him all over the world, from Africa to Antarctica. But it is actually his deep and profound faith in God and the Jesuit brotherhood, which has given him the reason to do his science. Indeed, for Brother Guy, doing the science is an act of worship to get closer to his Creator. So it's indeed fitting today that rather than bringing Brother Guy down to earth with us, let's go with him high up to the universe above and the Catholic cosmologies. Let's listen to Brother Guy expound on how our cosmos has been interpreted, from St. Paul's vision of hope and salvation to Galileo, St. Augustine, Kepler, Newton, Stephen Hawking, and the Big Bang. So with much pleasure, let's give a warm welcome to Brother Guy Consolmagno.
Thank you very much for having me. And I'm looking forward to sharing some of these ideas with you. So, Do we see it?
Yes.
Yeah,
Perfect.
got it.
Perfect.
We got it.
All right, finally. Let's start once again
Thank you,
with
thank
St.
you.
Paul in his letter to Timothy. There is one God, one mediator between God and humankind, Christ Jesus. God put this power to work in Christ when he raised him from the dead and seated him at his right hand in the heavenly places, far above all rule and authority and power and dominion, above every name that's named, not only in this age, but the age to come. You were dead through the trespasses and sins in which you once lived, following the course of this world, following the ruler of the power of the air, the spirit that's now at work among those who are disobedient. And then we also hear in Paul's letter to the Colossians, chapter 1, verses 15, Christ is the image of the unseen God, the firstborn of all creation. In him were created all things in heaven and on earth, everything visible, everything invisible, thrones, ruling forces, sovereignties, powers, all things were created through him. So we've done our reading from St. Paul. Now, I don't know about you, but when I go to church on Sunday, I hear a reading from St. Paul and I hear a gospel. And the gospel I remember because it's a great story. And the readings from St. Paul just go whooshing over my head because they're all of this theology that I can't pay attention to. It's utterly forgettable. At most, I'm going to hear words maybe that sort of make me go, what? What was he talking about? Mediator? Christ as mediator? But what's he mediating? I don't get that. Talking about heavenly places far above rule and authority and power and dominion. What is he talking about there? The ruler of the power of the air. What? Thrones, ruling forces, sovereignties, powers. What the heck is all that about? What it's about is cosmology. In fact, what we are seeing is St. Paul's idea of the cosmology. And when he was writing this 2,000 years ago, those words made sense to the people he was writing to, even though that cosmology is totally different from our cosmology. Cosmology just means words about the universe. The word was invented by a philosopher, Christian Wolff, in the 1700s. It's a kind of a metaphysics that talks about the totality of everything, the nature of the universe, using logic and reason. It's the world picture that a culture is going to assume that describes how the world works. It's like the operating system that your brain uses to fit all the different inputs of its senses that it's getting. A culture's cosmology can shape the discussions that individuals are going to have about how they expect the universe to behave. And it can also shape the questions that we as individuals ask, that the philosophers ask, that the cosmologists ask, and it can even shape the kinds of answers that we're going to find satisfying. From the early 20th century with quantum physics and general relativity, cosmology as a word was sort of taken over by the physicists and the astronomers, and it's a scientific description of how the universe works. But a cosmology can be outlined in ways that don't use physics or astronomy, and non-physical cosmologies play their roles in the way we approach the universe and the questions we really ask. And there's this feedback between the non-scientific assumptions of the universe and the scientific pictures of the universe. So you've seen this picture in a lot of the posters for the talk. Part of a cosmology is not only what do we look for, but how do we think people in the past have looked? Because everyone sees this picture as some kind of medieval view of the universe. Actually, it's not a medieval view of the universe. It's a Victorian view. It's a 19th century view. This picture tells you more about the mindset and the cosmology of the people in the 19th century than the people in the 12th century. It's not just that everybody in the 12th century actually knew the world was round, not flat. It's also an essential part of Victorian 19th century cosmology that they wanted to believe that people in the past were stupid, that they're superior to those crazy people who, were living in a flat earth. And if only they could peek through their dome of the stars, they'd see the mechanism behind everything. That was 19th century cosmology, thinking that they were better than those medieval cosmologists. It actually is true that there was once a time when people thought the world was flat. And if you go outside and take a look around, that's what you see. That's good astronomical observing. But that picture dates from about 2,500 years ago. It dates from the times of the Babylonian captivity. It was the best science of his day during the time of Babylon. You find this in Genesis. The first chapter of Genesis describes God creating a dome in the midst of the waters, separating the water above and the water below. And then between is the land where you get plants and animals and people. But many ancient cultures had similar pictures, but there's more than one heaven in these pictures. There's different layers of heaven according to your spiritual beliefs. I remember once I was giving a talk about meteorites. My science is, meteorites, rocks that fall from the sky. And I was giving this to a group of indigenous Native Americans in northern Wisconsin. And so I said, a meteorite is a rock that falls from the sky. And somebody in the audience raised their hand and said, which sky? That's exactly the way that people, before Ptolemy would have asked the question, because everything that moves at a different speed in the sky had its own sky. That was 600 BC. By 500, 400 BC, people already knew a different cosmology, that they knew that the earth was round. A lot of ways that the ancient Greeks knew that. And so instead of having a series of domes above the flat, they had a series of spheres, and each sphere was trapped in a different sphere that was orbiting at its own speed along its own axis. And this was the way that they could explain the very complicated motions of the planets. Eudoxus was the one who came up with this first theory, and it became the basis of classical cosmology, Aristotle's cosmology. Aristotle had this notion that there are different elements, earth and air and fire and water, and each have their natural resting place, and they will move to get to the place. So at the center is this brown stuff, that's earth. Above the earth is water. You drop a rock in water, it goes down, you have water in the earth, it bubbles up. Then you've got air outside of the water, so that if you have bubbles, the bubbles naturally want to go up. And in the air, you might have flames, so fire is the highest element. Again, this was perfectly good science. This was observing what was seen and making sense of it. There were these natural motions of up and down, but motions in any other direction were evidence of some kind of life, because here on Earth, if you move something sideways, it stops. But if you look at the planets and the stars, they keep going forever. So there must be a different kind of physics down here on Earth compared to up there. And if things are moving, then they must be alive. Things that are dead don't move, therefore things that move are not dead, they're alive. You can see the life in breath, and the word for breath in Latin is anima, so anything that has an anima is an animal. And anima also takes on the meaning of soul and life. And so each of the spheres that carries a different planet seems to have its own life. And if there's more than one sphere accounting for all the different crazy motions, then they each have their own spirits. One thing to remember is that the Earth is not the center of this system. The Earth is the bottom of this system. The planets are perfect and wonderful, and maybe out at the farthest reaches is where you'll find God. Here on Earth, things are corrupt, things wear out. Eventually, the theologians would say that was, the effect of original sin. And if you think that the Earth was the center, then what about, hell? Hell was fire and brimstone. Look at a volcano, you can see the fire and brimstone inside the Earth. If you think that the Earth was at a special place because it was at the center, then you're completely missing out the meaning of, if the Earth is at the center and better, well, the hell is even at the center of the Earth. So make hell even better than the Earth. No. Earth is at the bottom of the universe, and the only thing lower is hell. That's an important distinction that a lot of modern readers, again, not educated in the cosmology that picture was coming from, will get wrong. They think that the centrality of the Earth means that it's a special place. No, It's just that it's the only place. Rocks can only go in one direction. That's a classic case, by the way, of an assumption so basic that the people making the assumption didn't even realize they were making it. Actually, if you want to know more about this, I recommend you a book by C.S. Lewis called The Discarded Image. We know C.S. Lewis is the guy who wrote the Narnia books, but he had a day job. He was a professor of Renaissance and medieval literature. To understand the literature of that time, you've got to know the cosmology of that time. And so he explains how, hell is not really the center of the universe and God is at the most distant reaches. It's an inversion of reality. God is at the center and we're really as far away as can be. Maybe some of you have heard of the different ranks of angels that people talked about in the Middle Ages. There's angels and archangels and virtues and powers and dominions and thrones and the cherubim and the seraphim. Recognize some of those names? Powers and dominions and thrones. Paul's referring to them in the letters I just quoted. In the Middle Ages, sometimes they're identified with each of those spheres of the planets, and therefore they are the spirits causing the different planets to move in their own spheres. And there's this whole population of angels and demons and geniuses moving among the ethereal regions. And that's what St. Paul is talking about. And you recognize that when you see these names, principalities, thrones, dominions, you're not just talking about the kings that are around when people are writing about that. You're talking about the planetary intelligences, the things that seem to be moving those spheres to make the stuff in the sky appear to move. So, even this goes back to the book of Daniel. Kingdom and dominion and the greatness of the kingdom under the whole heaven. Well, that's where God is. And these are all the spheres underneath that. That's going to be given to the saints of the Most High. And all dominions, all of those spheres are going to be under God. Because that's the point that St. Paul is trying to make in those letters. Remember the letters? I started with the letters. You're trying to get those letters up on the screen. Brian Purfield wrote a wonderful article for the British website thinkingfaith.org. And he interprets Paul's letters as a reaction, not that we have to accept this cosmology, but Paul is saying, actually, no, that's the cosmology of your culture, but Christianity is telling you something new. As Father Purfield puts it, the people in Ephesus and in Colossia already had a view about the world and their place in it. And according to the worldview, the gods are up there beyond the sky. People are down here on earth. Between the gods up there and the people down here, there are all of these spheres, all of these intermediaries. If you're going to live a good, happy life down here, you got to keep those intermediaries happy. And so you burn little sacrifices here and there, because each one of them is going to be in charge of some part of your life. And Paul's saying no. Paul had heard from Colossia about how people were adapting Christianity to their culture, to their cosmology. So when the Gospels reached the Colossians, and the Colossians hear the Gospel, they're told that Jesus is the mediator before God. And they're going to, but we've already got these mediators, right? How does Jesus fit into the system? They're trying to take the gospel message and superimpose it into their already existing worldview. And that, though we criticize it, is in fact what everybody does. It's also what we are doing. And we will wind up making assumptions about the Gospels in terms of how we expect those pictures to work. I recommended this Discarded Image book. It was a beautiful cosmology, that Middle Ages cosmology. Few constructions of the imagination had splendor, sobriety, and coherence. It only had one problem. It's not true. Nobody's cosmology is actually completely true. Cosmology is more than just how things are arranged. It's also a question of what you expect the universe to be like. Most cosmologies through history have started with the idea of a golden age. You know, we've got the biblical story and later in Genesis of the fall of mankind. The sense is that the earliest people were closest to God and they had all this knowledge, and generation by generation, things have gotten worse and worse and worse. And certainly, you know, my grandparents told that about me, and now I'm telling that to what do these kids know? They don't have the good music we had. Things are always getting worse. It's not only in the Bible that you find that. You find that in ancient legends of Atlantis, which was, you know, Plato's dialogue, the Critias, where Atlantis was supposed to be the apex of civilization, perfect in every way, and it's lost. The only place where you can get the knowledge of Atlantis was from Egypt, which was the oldest civilization that they had. That's also why they were so credulous about anything written down, because books were written and voices from the past when people were smarter. Living as I do in Rome, I can understand completely why people in the Middle Ages thought that, because you wander around Rome and you look at these enormous buildings that the Romans left, the aqueducts, the Forum, the Colosseum, and it's the Middle Ages. And at this point, Rome is a pretty dinky place. And you realize, boy, 1,500 years ago, those Romans really knew what they were doing. And we don't know how to do that anymore. I don't know how many of you have read Jane Austen and her stories, you know, set in Bath in the early 1800s. The baths in Bath were built by the Romans, and even the people in the early 19th century didn't have the technology to match what the Romans had been able to do. Everybody knew, as their cosmology up through the Middle Ages, that things were better in the past and are continually decaying. And the best we can do is to try to grasp a little bit of what those smart people in the past were able to do. That's what everybody in the past knew. By the 19th century, though, there is a totally new everybody knows. It's sometimes called Whiggism. That idea that the people in the past were stupid, ignorant savages, that civilization accumulates knowledge slowly and painstakingly, and science will make us better and better, and we're going to have, you know, electricity and steam engines, and that will solve all of our problems. That was the cosmology of the 19th century. And you still hear echoes of that in various places even today. Even though if you look at, you know, the wars of the 20th century, you realize some of the most sophisticated civilizations with the best technology were not necessarily really nice places where you'd want to live. One of the shifts occurs at the time of Galileo. For one thing, Galileo, for the first time, is discovering things that are not in books, and he's doing it by using a telescope. And not everybody had telescopes in those days. Not everybody even understood how telescopes worked. In fact, Galileo didn't understand how the telescope worked. He had the advantage of having glass from Venice, which was the best glass in the world, so he could make lenses that didn't have bubbles and didn't have flaws. And one of his challenges was to be able to make enough telescopes so that other people could see what he could see. Because for the first time, to be able to understand the universe, you needed a tool that other people didn't have. One of the other tools that people didn't have was mathematics. And suddenly, with Copernicus and his idea, I show you here in this picture, two different slides. One is the Copernican system that everybody's familiar with the sun at the center and all these nice circles. And the other is what Copernicus actually wrote in his book, which is a heck of a lot more complicated because Copernicus still used circular orbits. He was still attempting to work out the motions of the planets, even though the sun is kind of at the center. It's not exactly at the center, and it makes a tiny circular motion. And all of the other circles are circles within circles in order to match the appearances of what's actually in the sky. The mathematics of how the planets move, this new tool of mathematics that not everybody has, is due to Kepler. And Kepler says that planets don't move in circles, they move in ellipses. But it's interesting to see why he says ellipses. Is it because ellipses mean you don't have to have that crazy collection of circles within circles? No. You actually look what Kepler wrote. There's a a letter in a wonderful book by Job Karantaram, a philosopher of science and a Jesuit, the guy who taught me my philosophy of science. And he quotes a letter from Kepler to Herbert von Hohenberg. One of the reasons was the mystical significance of the structure of the universe. Because Kepler writes, the center is the origin and beginning of the sphere. The origin has precedence everywhere. When we apply this consideration to the Holy Trinity, the center must refer to God the Father. So the sun, which is the most amazing thing, must be God the Father. The light coming off the sun is the Holy Spirit. And this is a crazy theology. Not even anybody else in Kepler's time believed that theology. But this is the theology that forced Kepler to have the sun in one unmoving place, which happened to be the focus of an ellipse. This crazy theology led him to the idea of an ellipse. And the idea of the ellipse is important, not just because it does a nicer job of describing the motions, but because the mathematics of the ellipse eventually leads Newton to come up with his mathematical law of the motion of planets, the law of gravity. Notice a common trait in everything up to this point. When you're trying to put the pieces of the universe together, there is this unspoken assumption that when you're talking astronomy, you're also talking religion. One tells you how to go to heaven, the other tells you how the heavens go, but they're still, as far as they're concerned, talking about the same heaven. That divide finally comes with Newton. Again, the contrast between our cosmology and the cosmology of the past. To the modern mind, nature is a mechanism. It operates by rigid rules. There are these laws of physics, and the mechanics of the universe can be established in the physics. And even though we've got quantum physics that shows the universe is not quite so mechanical, still, even if the universe is at a certain level only deterministic, not deterministic, but probabilistic, quantum physics can tell you what are the odds of one kind of physics over another. In Newtonian physics, the hallmark of a successful experiment is that you can repeat it. In the post-Newtonian world of quantum physics, some outcomes can't be predicted, but they're predictably unpredictable. But in the medieval world, nature's not a machine. It's more like an organism. You can see these different patterns of behavior. Think, for instance, that maybe every day as the sun comes up, you go to pick up the newspaper in the front of your house and you see a cat at the door. So you leave a treat for the cat. You're not surprised to see the cat. Cat seems to be there every day. But if one day the cat doesn't show up, you go, well, cats are like that. You don't think that some physical law of the universe has been violated. These things happen. In a world with limited experience of machinery, the normal, most complicated thing that human beings see is organic entities, plants and animals. If crops failed, a pagan might offer a sacrifice to the goddess Ceres. A post-pagan Christian might pray to Saint Isidore the farmer. A fatalist might just say, these things happen. It's in the Newtonian world that you start asking, well, maybe we can try to predict the weather. Maybe we can try to predict by putting chemicals in the ground that we can make food better. Understanding climate and weather patterns certainly was beyond medieval technology. It's actually pretty much beyond what we can do even today. A strict 19th century materialist expects that for everything that happens, including the weather, it happens because of some simple and mechanical reason. And when things don't work, we want to know why. An example of that is the mystery story. Think how mysteries are suddenly beginning to be written, Sherlock Holmes and the others, by the 19th century. Now, some of you are going to say, what about the story of Daniel and Susanna, chapter 13 of the book of Daniel? Isn't that the world's first mystery story? Well, yes and no. Actually, mysteries in the modern sense operate under rules that are as rigid as the rules of chemistry, and these rules of detective writing were actually spelled out in the earliest 20th century by mystery writers like G.K. Chesterton, Ronald Knox, Dorothy L. Sayers, who all of them actually happen to be religious apologists. Father Knox writes this code for how you can write a mystery story that says no accident must ever help the detective, nor must he ever have an unaccountable intuition that proves to be right. So go back to the book of Daniel, the story of Susanna. I don't know how much you know of the story, but basically Susanna's this wonderful girl. A couple of dirty old men watch her, and she won't have anything to do with them. So they say that they make a claim that they saw her doing terrible things. Daniel stops the crowd from stoning poor Susanna by asking which of the where were you standing when you saw her, and they each give a different answer. The villains aren't caught by physical evidence or even by rigid logic. The villains reveal their guilt merely because they contradict each other in a really minor part of their testimony. We're not even given Daniel's insight into asking them for that, what tree were you under? Did he have one of those unaccountable intuitions that, Father Knox says you really shouldn't have in a mystery? For the ancient audience, hearing the story of Daniel and Susanna, that doesn't matter. The point of the story for them wasn't to work out the puzzle of what happened, because they know what happened. That's given to you at the beginning of the story. The puzzle isn't even how the truth is going to be brought to light, because at the end, it's not Daniel's cleverness that's praised. It's not Daniel's logic that's praised. Instead, the whole assembly raises a great shout and blesses God who saves those who hope in them. Daniel might be the hero of the story, but his heroism is derived from his closeness to God, merely a reflection of the goodness of God. That's a very different cosmology from the mechanical cosmology that gives us cause and effect and logic and eventually the mystery story. The new physics of Newton gives this replacement for Aristotle in Aristotle's old system. It reproduces the elliptical orbits that Kepler had come up with, for a theological reason, using formulae based on physical laws that act the same way on things up in the sky and apples falling from a tree. The Earth and everything on it is no longer at the bottom of the chain of creation. It's at the same level as all the other planets. And this gives rise to a new assumption, a new cosmological principle, that there is no privileged place or really unprivileged place in the universe. The laws that govern the universe are the same everywhere. Deductions about the universe that you deduce from seeing how things work in the lab in, Singapore would be the same as a lab in England, would be the same as a lab on a planet around Alpha Centauri. That's the basis of modern cosmology. And that leads to a divorce between human free will and the workings of the physical universe. Because it seems to imply that everything, if we're mechanical, chemical animals, we're also, under these same laws of physics, and there's no free will, therefore there's no sin, and therefore you've got this universe where just learning more science will replace the need for redemption. Well, there are a lot of problems with Newton's physics. His laws of physics depend on knowing the forces, like the force of gravity, but you have to apply the gravity to the exact position and the exact time and the exact velocity of that thing, and you had to spell out in some sort of detail how you measure that exact position and that exact time. And that's really not intuitively obvious. Ask anybody who's tried to teach freshman physics to university students. It's not at all obvious. Eventually, you just buy into that new physics and you have this new way of thinking about it just by living in it so long that, you don't even ask questions about it anymore. As any physics teacher can testify, it takes a long time to get there. It takes a lot of time and effort before these get incorporated into a new kind of intuitive common sense about how the universe works. The mathematician John von Neumann said this about math, but it's also about true physics. You never really understand physics. You just get used to it. There's a more subtle problem with Newton's physics, even beyond the fact that you've got to have these exact positions, which quantum theory tells us don't exist. Look at this hose. Say you turn on the water tap and the water goes through and around and around and around and around and around and around the hose. If you were somebody from Aristotle's time, you'd think that the water had been trained to go in circles and it might go around and around even after it comes out the end of the hose. If you're a physics teacher trying to teach, freshman physics, you're going to say, no, after the water comes out of the hose, it's going to go in a straight line because there's no other force acting on it. And that's Newton's second law. Anybody who's actually turned on the water in a hose knows that what really happens is that the hose goes flying all over the place. The pressure of the water and the size of the hose turns out to be so complicated that, yes, if you have an infinite amount of computer time, you might be able to model it. But reality is far more chaotic than can be easily solved by Newton's physics, except in the simplest cases like planets where there's no friction going on. And that's one of the reasons why the weather is so hard to predict. There is another problem with Newton's physics. Newton says that the planets move in their orbits because of gravity. So what's gravity? Well, here's our copy at the Specula of the Newton's Principia Mathematica. We don't have a first edition, only a second edition. And if you look at the very end, he says, you're going to ask me in Latin, well, what is gravity? And I tell you, here are the equations that describe how it works, but as for what it is, hypotheses non fingo. I feign no hypotheses. I've no idea what it is. I just know how it works. The first modern to try to come up with an idea of gravity was Einstein. And he says that gravity is the warping of space and time. So if you've got this really bright thing in the bottom left here, that's actually a galaxy of billions of stars. There's so much mass there that the area, the space-time around it, bends the light of anything behind it into these weird circular forms. They're called Einstein rings. According to Einstein, what appears to be the measure of mass and time and distance, the things that you had to be able to measure to do Newtonian physics, the measure of those in one frame of reference can look really different in a different frame of reference. Every event can be fixed in space and time, but its location in space and its location in time will have a different measure from different frames of references. And then quantum physics says you can't even measure it perfectly anyway. All of that is to say that while Newton did a great job, a better job than Aristotle, to be able to describe the motions of the planets, Newton wasn't the final word. Now, here on the left, we've got an astronomer, Arthur Eddington. Arthur Eddington is the guy who went off to Brazil in 1919 at the time of an eclipse of the sun, so that he could see the light of a star that would be right next to the sun that normally you wouldn't be able to see because the sun was too bright, but when the sun's blunked out by the moon, you can see the star. He measured the exact position of the star. He noticed that that position of the star was shifted from where it was supposed to be because the starlight had passed near the mass of the sun that had bent the space-time continuum near the sun in just the way that Einstein's theory of general relativity predicted. This was the first and most dramatic evidence that Einstein got it right. Now, if mass warps space and time, then the whole mass of the universe, its total gravity, should be pulling every other piece of the universe together, and all of the universe ought to be collapsed down into one point. Newton had argued that the same laws of gravity that worked on Earth would work on the stars and planets. The cosmological principle is that there's no place different from any other place, so that the only way it couldn't collapse on itself was that if the universe is infinite in space and infinite in time, and therefore all the pieces can pull in all the other pieces without one place wanting to be where it's drawn from. And therefore, it's boundless in space and boundless in time. But that didn't work with general relativity. Now, the fellow on the right with the familiar looking collar is a fellow named Georges Lemaitre, who had 2 doctorates, one from Louvain in Belgium, one from MIT, my own alma mater. He also happened to be a Catholic priest. And he was not afraid to think of a universe where things could move. And he said, if you have a universe that has a beginning point and things are, as their initial conditions, moving away from that beginning point, you can then come up with a way that you can stop the universe from collapsing in on itself. But the only way you can do that is by having a beginning point. Here's a picture of him at Caltech with a couple of the other greats. Of course, you recognize Einstein on the right. The fellow on the left was Millikan, who worked out with the nature of the electron. Einstein says, your mathematics, I can't find any flaws with it, but the idea of a universe having a beginning, he had a hard time believing that. Lemaitre referred to this theory as the primeval atom, an atom of almost infinite energy and no space. One of the people who hated this idea because, you're just a Catholic priest, you're just trying to come up with the idea of the universe having a beginning. Ha! One of the other people who made fun of it was Fred Hoyle, who gets on BBC radio and makes fun of this theory by calling it, Father Lemaitre's Big Bang theory. The Big Bang violates the cosmological principle because it says there's a time different from all other times. There's a starting point time. But then the astronomers start noticing that galaxies are moving away from each other. And Edwin Hubble says that the farther away they are from us, the faster they're moving away from us. So if you run the clock backwards, they actually all were at the same place at the same time. And not only that, but the energy of this infinite energy of a tiny point, by the time you get to a universe as big as we are, the energy should have spread out and cooled down to about 3 degrees above absolute zero. And with microwave radiation, you can actually see that radiation. And there are a bunch of other places that proved ultimately that Lemaitre's Big Bang theory does a better job than anybody else's at describing what's going on. So how does that fit into Catholic theology? Does it show that Genesis was right? There really was a creator God? Not necessarily. Stephen Hawking, an atheist, made this statement: because there's this law such as gravity, the universe can and will create itself from nothing. What he meant was, before there's anything, when there's just a vacuum, there's this background space-time continuum, but because of quantum uncertainty, sometimes it will have some tiny fluctuations, and if you wait long enough, one of those fluctuations will be really, really big, and that fluctuation, that bending of space and time, is what we call gravity, and because there's gravity, then the universe will spontaneously generate itself, and therefore you don't have to invoke God to start the universe. And he uses that with his co-author Leonard Latimer to sell books about how he can come up with this book, The Grand Design. And this is a shouting point of the new atheists. Nothing new about that atheism, of course, but it just gives him the idea that I've shown that God is obsolete once again. The trouble is that the God they're talking about is not the God of Scripture. If you think of God as the thing that started the Big Bang, the thing that started the universe, and then you say gravity is the thing that started the universe, you're not saying there's no God, you're saying that gravity is God, which is kind of goofy. I don't think that Stephen Hawking actually believed that gravity was God. Of course, that would explain why Catholics celebrate Mass Those of you who have taken physics will get the joke. The rest of you just let it go by. There's this deeper problem. Newton had this idea of God. Newton was a deist. Newton did not see God as personally involved in the lives of human beings, but just as the prime mover, you know, the one who wound up the watch and let it get going. And with that vision, there's no split between science and religion because, you know, religion just allows to explain how the universe gets started. But that reduces God to something that fills the gaps of what we don't understand. Well, God must have done it. And then once you filled the gaps, and suddenly you don't need God. It also reduces God to nothing more than Zeus throwing lightning bolts. Suddenly God is nothing more than a nature God, somebody, you know, that you pray to get the crops to grow. God, this kind of God, according to Stephen Hawking and the others, is that God is just what you need to start the Big Bang, and I figured out why you don't need God to start the Big Bang, and therefore there is no God. And he's right if that's your picture of God. The picture of God that he's overthrowing is a God who just is one force alongside all the other forces in nature, you know, gravity, electricity, and God. And that God is no longer supernatural, outside of space and time, there from before the beginning. It's just a nature pagan God. And I don't believe in that God either. What does our God, what does the idea that comes from our cosmology of God tell us? Book of Ecclesiastes has this marvelous beginning, vanity of vanities, all is vanity. The British Lord Jonathan Sacks, the chief rabbi of the United Kingdom, translates this as meaningless, meaningless, says the teacher, utterly meaningless. The universe is meaningless. As one dies, so dies the other. And Rabbi Sacks says, that's exactly right and exactly self-consistent if you're looking for meaning in the universe itself. It's only the supernatural God of Genesis that allows the universe to have meaning. The gods of paganism within the universe cannot give meaning to the universe any more than a chair has meaning without the person who's not the chair sitting in the universe. The sense of the world must lie outside the world, which brings us back to Genesis. That Genesis picture of the universe is based on Babylonian science, the best science of the day, and you can find a lot of parallels between the way that the universe is described in Genesis and the world that is described in the Babylonian pictures. But what's different is the way that the universe is described and God is described in Genesis compared to the Babylonians. It starts in the beginning, God's already there. God's already there before there is a universe. This is the discovery of God beyond the universe. This is a God who is not pulling and pushing things to make them happen, but a God who sets up laws that we can discover. A God who creates in a way that is so systematic that day follows night and motion follows motion, and these laws can be understood by us. This is a universe that is done by the will of God, not by the accident of the gods doing other things, killing dragons or whatever, like in the Babylonian myth. By the word of the Lord, the heavens were made. The world comes about as the result of a decision, not by chance. The creating word, let there be light, expresses a free choice. And it occurs in a way that everything can be seen, nothing is hidden. Let there be light. Light allows life to be possible, choice to be possible, encounter to be possible, freedom and progress to be possible. And finally, the ultimate goal of creation, in the Babylonian myth, it was the city of Babylon. But in the Genesis story, it is the Sabbath, the day of rest, when we can contemplate God and contemplate God's creation. The work of the other 6 days is what you do to, be able to eat and sleep and have food. But we don't live by bread alone. Our ultimate goal is to be able to have a seventh day when we can do astronomy or poetry or dance or all the things that make us more than just animals eating and sleeping. Science is a system of logic that starts with assumptions that says the universe is real, created by a real God, that follows laws. It's not chaos, or it's not the action of nature gods. And it's a universe that is so good that it's worth our time to learn those laws. That is the Catholic cosmology that allows science to even happen. If you want to know more about the work we're doing at the Vatican Observatory and hear other people's takes on this, I invite you to come to our website at vaticanobservatory.org. And thanks a whole lot for being with us.
Totally enthralled by your lecture, Brother Guy, so stimulating. And there are a few questions, so I'm going to get on with it. But I want to thank you personally first for such a beautiful lecture on how God fits into the universe and how science doesn't contradict the existence of God. Thank you so much. Anyway, as a Jesuit, one of the questions that we have for you is about a very famous Jesuit, Teilhard de Chardin, and his evolutionary cosmological vision of Christogenesis, that Christ is not only God, but man, and also the third aspect, the third nature, which is the cosmic Christ. Can you explain what this cosmic body of Christ is and how the universe is engaged in Christogenesis as it evolves towards its full realization of Omega, the point of super consciousness, when, as St. Paul said, God will be all in all. And of course, St. Paul's cosmic theology fully recognizes the absolute primacy of Christ. Sorry, it's a very long question. Over to you.
Fortunately, I have a very short answer. Your question is, can I explain that? And the answer is no. I'm not an expert on Teilhard. I can't even begin to go into the depth of his wisdom. I'll say that what I love most about Teilhard from what I've read is not necessarily his answers. I'm not sure I buy his answers, but I love the fact that he's asking the questions. And I think he was probably the first to really take this new cosmology seriously and try to wonder about what are its implications. I will mention somebody who I know has written a thesis on Teilhard, and that's the speaker you're going to have in a couple of weeks, Paul Muller. So you might want to bring the question back to him in a couple of weeks' time. He knows much more about Teilhard than I do.
Okay, then back to science, Brother Guy. You've already mentioned Newton's physics, and we'll bring you back to another scientist, Stephen Hawking, who already you mentioned he has, as an atheist, removed the need for God. And you have already mentioned that, given so many brilliant answers as to why, as to counter this. But I'm sure.
And the point I want to make is Hawking is right. The God that he does not believe in, I don't believe in either. Hawking only believes in one less God than I do, because I only believe in one God. And that means there's a whole, world, pantheon of gods that I don't believe in. I only believe in the God of Scripture. I only believe in the God of love. I only believe in the God who is present at every place and every time and creates at all times, not just 13 billion years ago at the Big Bang. Creation didn't end then. God maintains the universe. God allows the possibility of existence. That's what God's creation out of nothing is. It's not a random fluctuation in the space-time continuum. It's why we've got a space-time continuum in the first place, and one that behaves in such a way that it can fluctuate.
Yes, and indeed, for the universe, our universe is logical, and it has rules.
And there's no reason why it should be, but there it is.
And God made us, and we can love with our heart, our mind, and our soul.
Because we do this science not just because it's logical, but because it's fun. Yes. God creates a universe that's beautiful and full of love and full of fun. And you're not going to find that in any physics textbook.
Well, speaking of fun, I have a question for you about your book, your very popular book, Would You Baptize an Extraterrestrial? So do you believe there are other intelligent life on other planets? Are humans the only, of course, you already answered this in your lecture, humans are not the only creation of God. How does God prepare us for all the extraterrestrials out there?
When you're a baby, you may not have remembered this, but anybody who's watched babies will tell you there comes a time when babies suddenly realize that there are other babies. And this is the shock and an explosive. It doesn't make the personhood of the baby any less to realize that there are other babies. But those other babies are as alien to them as, creatures in Alpha Centauri might be to us. I have no data. I've got no reason to be sure that there's life elsewhere in the universe. I think it's worth looking for because I think it's likely enough that it's worth looking for. On the other hand, I have no confidence at all in people who are looking for UFOs. To me, those people are, they've rejected God and they're looking for something else to replace God in their mind. And frankly, I think the God of Scripture is a whole lot deeper and more wonderful than any creature from a UFO. Thank you very much. And with a whole lot better evidence than the evidence for UFOs. But don't get me started in UFOs. Total waste of time. But it's a big universe. And not only is it big in space, it's also big in time. So even if we were the only intelligent creatures in all of the galaxies that we could see right now, who knows what the universe is going to look like in another 10 billion years? What I do know is that all of us are creatures of the same creator. And the bigger I see the universe, the more I appreciate how big God is. And this is not some new insight from modern physics. You find this in Psalm 8. At the very beginning, the psalmist says, "You're so big, the universe is so big, I'm so small, and yet you have made us little less than the angels." How is this possible? It's possible because God is infinite and can put all of God's attention on me and also on Joan Fu and also on each of the other 100 people listening to us right now. Because that's what God's infinity means.
Amen. It's faith. It's God doesn't need to be explained.
It's also the experience. I know that God loves me because I've experienced God's love. And so if I'm going to come up with a cosmology, it's a bad scientist who throws away the data because it doesn't fit your preconceptions.
Okay, I have a last question for you, a very scientific one from one of our participants. How did Hermetic philosophy shape the early scientific views of the Roman Catholic Church?
I'm not sure that you could talk about the early scientific views because the word science itself didn't even exist until the 19th century. Before then, what we would identify as science was called natural philosophy. And a principle, which is a perfectly reasonable principle, but it's sort of enshrined in Thomas Aquinas, is that philosophy's got something to tell us. We should listen to the best philosophy of the day, but we shouldn't think that it's the sum and the end of the story. If you think your knowledge of God is full and complete, then your faith is dead because you're never going to learn anything more about God. If you think that your understanding of the physical universe is complete, you know, you're never going to be a scientist because the first thing every scientist knows is to go back to the funding agency and says, I need more money because there's more to be learned. But in every step along the way, science can rescue religion from superstition. Religion can rescue science from false absolutes. Each of them, science and religion, is a road to truth that supports each other while giving each other its proper autonomy. And that's not Brother Guy saying that, that's Pope John Paul II saying that. And that was in a letter that he wrote on science and religion to my predecessor, Father George Coyne, when he was the director of the Vatican Observatory.
Thank you very, very much, Brother Guy. And for all that, there were a few little questions here and there we can always answer by the email. And I'm sure for all of us, some of us actually from Asia are your captive audience. We're in lockdowns, but we are also your captivated audience. Thank you, Brother.
Thank you very much. And I hope you guys will spend the time just to take a look at the VaticanObservatory.org website and see the sorts of things we do and the kind of conversations that we have all the time, because science and religion are both conversations that I may be doing my science in front of a computer by myself, but I can only do it with a community of people around me that we can carry this conversation on. That's why we've got museums. That's why we've got organizations like yours. Thank you so much for letting me be part of it.
Thank you, Brother Guy. And maybe one of the trips by the Asian patrons of the Vatican Art Museum will be to your observatory so that we can stargaze with you.
We have done this with other groups of Friends of the Observatory. If you come out here to Castel Gandolfo, which is where I am right now, you can see the Papal Gardens, you can have a wonderful Italian dinner, and then from there it's a short walk up to our telescopes. You can see our museum, and if it's in the evening, you can even look through the telescopes.
Wonderful. So we have more reason to join the APAVM. Thank you.
Absolutely.
Thank you. So next week, next Saturday, we have another treat. The topic next Saturday is transhumanism, the imperfect scientific quest for human perfection. And it's given by another very interesting speaker, Father Michael Baggett. I hope you will join us next Saturday at the same time. And you can always register. Those who have registered, you can use the same Zoom. It's the same every Saturday. And this brings me to a short commercial on the Asian patrons of the arts in the Vatican Museum. I'm a patron, and everyone here, all of you who are watching today, actually, this whole series have been sponsored by the Asian patrons of the arts in the Vatican Museums. And it would be wonderful if you could join us too. We go on very nice trips and we have great lectures. Best of all, we help to preserve the art of the Vatican Museum, and the Asian chapter is helmed by the very energetic and robust chairman, Ben Chang. Thank you, Ben, for helping put all this together. Bye-bye.